This video will focus on surface area and volume of the sphere. Now you can think about a sphere like a ball. If you want a more formal geometric definition, we're going to say that it is the three-dimensional figure in which all points on the surface are equidistant from a single point called the center. Because a sphere is not made up of polygons, it is not a polyhedron. Let's talk a little bit about the cross-section of a sphere. If we take and slice a sphere, any way we slice it, that cross-section is going to be in the shape of a circle. Now, if that circle happens to be the biggest circle that can possibly be drawn and passes through the center of that sphere, we call that resulting circle a great circle. Some interesting facts about the great circle is that the great circle is the biggest possible circle that can be drawn, or a cross-sectional piece of the sphere. An example of this on Earth is the equator, and that great circle will divide the sphere into two equal hemispheres. A couple of other interesting facts. Anytime you're going to take the shortest distance between 2 points on a sphere, it's going to be along an arc rather than along a line segment, so along that curved surface of the sphere. The great circle is an example of a geodesic, which is the shortest distance between any 2 points on the surface. Formulas that you're going to need to know how to be able to use for the sphere deal with surface area and volume. In order to find the surface area of a sphere, you're going to multiply 4 times pi times the square of the radius. Volume you can find by taking 4/3 and multiplying that times pi times the cube of the radius. So let's go ahead and get into some examples of how these formulas work. In number 1, it talks about the volume of a sphere being 5,000 cubic meters. It wants us to find to the nearest hundredth the radius of that sphere. Since we're talking volume, I'm going to make sure that I use the formula for volume. So formula for volume of a sphere is 4/3 times pi times the radius cube. Now I'm going to go ahead and substitute into that formula everything that I know. The volume of that sphere is 5,000, so I'll plug that in on the left side of my formula. The 4/3 is going to move down to the next line. The pi will move down to the next line, times r cubed. At this point, I've now substituted everything into the formula that I can, and I need to solve this equation. In other words, I want to get r all by itself and undo all of the algebra that has been done to the radius. So to undo multiplying by 4/3, I'm going to begin by dividing both sides by 4/3. So when I get my calculator out and type in 5,000 divided by the fraction 4/3, I end up with 3,750, and that's going to be equal to pi times the cube of the radius. So that's looking a little bit better already because I eliminated the fraction. To undo multiplying by pi, I'm going to divide by pi on both sides. So now I have on the right side r cubed, and on the left side I have that 3,750 divided by pi. To undo cubing my radius, I'm going to take its cube root. And if I take the cube root of the left side, I have to take the cube root of the right side as well. And this is going to call for you grabbing your calculator and punching this into your calculator. You want to type in the cube root of the fraction 3,750 divided by pi. And you should be typing this in with me as I go along so that you can get the practice using your calculator, and that way on test day you'll feel very confident that you know exactly how to enter these numbers into your calculator. So the radius here is going to be 10, and I'm going to go ahead and put those decimals down, 6078, and then some other things that come after. But since they want me to round to the nearest hundredth, I really need to focus in on that place right there. To the nearest hundredth, my radius is going to be 10.61. All right, so when all is said and done and I round that radius to the nearest hundredth, I end up with 10.61. Now, ordinarily, we would never use a rounded answer in any of our computations, but the directions here specifically say use the answer we found in Part A. And the answer that we found in Part A is this rounded answer. And it wants us to now go ahead and find the surface area of that sphere. So I'm going to go ahead and use the formula for surface area, 4 times pi times r squared. And I'm going to go plug in that number that I got for the radius. So 4 times pi times 10.61 squared. All right, so on the right-hand side of this equation, I've got really a couple different things going on. I've got the operation of multiplication, and I've got this 10.61 being raised to the second power. PEMDAS and SALE, order of operations, however you want to think about it, says the very first thing I need to do here is raise that 10.61 to the second power. So I'm going to go ahead and multiply 10.61 times itself, or in other words, raise it to the second power. So when I do that, at this point, I haven't done anything with the 4 pi yet. So I end up with 4 times pi times 112.5721. And now, since it's asking us to round our answer to the nearest tenth, I'm going to get out my calculator and I'm going to type in 4 times pi times 112.5721. And when I do that and plug it into my calculator, I end up with, for the surface area, 1,414, and then a whole bunch of decimals. I'm going to write down at least 2 of them on my paper. And then I'm going to do as the directions say, and I'm going to round this number to the nearest tenth. So to the nearest tenth, the surface area here is 1,414.6. And I want to either say square meters or meters squared. So there it is, folks. That's the sphere. Like always, I want you to summarize in your own words the key ideas and important understandings that you'll need to remember from this video, and then see if you can apply what you've learned in order to solve questions 2 and 3.